Hello everyone and welcome to this video. In this particular video, we are going to talk about the gel filtration chromatography concept. So from our previous video, we know that the gel filtration chromatography is based on the size. So in gel filtration chromatography, the column that we use is packed with the bead containing pores, and these pores actually allow the entry based on their size. So if the size of the molecule is bigger, they simply bypass the bead, and if the size is smaller, they can pass to the pores. So what happened in normal sieving? As we sieve, so the bigger molecule get trapped on the sieving tool and the smaller molecule get eluted first. But in gel filtration chromatography, the separation of the larger molecule is first and then afterwards the smaller molecule. Also, the separation of molecule occur due to the retention time of the molecule in the bead. So larger molecule get out first, then the smaller one. And here the size which we are referring to is directly proportional to the mass of the protein. So the protein that we use is the globular protein, but not the fibrous one. Why we use the fibrous one will come in the upcoming slides. So this is the bead that we use, and these are the molecules for the separation. So the pink species is bigger than this pore size, so they simply can bypass the bead, but these green species are actually can fit into these pores. So when we run this buffer, so the pink species easily bypass the bead and the green species come through the pores. So this is how the gel filtration chromatography works. So if we look at the column, so again here we have a globular protein, and as we run, so the same thing happens. So the larger molecule get eluted out first and then afterwards the green species. So even if one or two a small molecule bypass one or two beads, but there will be a much more layer, so they will get trapped into other beads. So now if we look at the absorbance spectra of these molecules, so what happens is, as we know, the larger molecule will come out first, so it will give us a spectrum, and after some time the smaller molecules will come out, then it will give another spectra. So why don't we use the fibrous protein is simply because the fibrous protein are the in the linear dimensions. So if they are moved through these pores, so what happen is they'll simply block this pore and there will be no elution. So elution of the fibrous protein by gel filtration chromatography is basically illogical. It simply clog the chromatography column. So that is why we only use it for the globular proteins. Now coming to the elution volume. So what do I mean by the elution volume? Because we have to elute this molecule from this column. So we know that the larger molecule will can easily come because they'll simply bypass the bead. So we'll need a much less elution volume for the larger molecule. But for the small molecule, we'll be needing a much larger volume because they will be trapped in these pores. So we have to run more and more buffer so they can come out. So just suppose if the total column volume of the gel is Vt, so the Vt is given by Vg plus Vi plus V0. So Vg is the volume of gel matrix or the volume of the bead, Vi is the pore volume, and V0 is the void volume. So here we see the gaps between the 2 or 3 beads, so which is called the void volume, and the pore volume is the pore which is in the bead is the pore volume. So the mobile phase volume required to elute a molecule from a column is the elution volume. So how do we calculate it? So elution volume is actually related to the void volume and the distribution coefficient. So V equal to V0 plus Kd into Vi. So from our previous video, we know that the Kd is the concentration of a molecule in a stationary phase by the concentration of molecule in the mobile phase. So if we calculate the Kd will be Ve minus V0 by Vi. So Kd is the ratio of the inner volume available for a molecule and is actually independent of the column dimension or geometry, because Kd is dependent only on the stationary phase and the mobile phase, and it is dependent on the how molecule interact with the stationary phase. So if it interact with stationary phase more, the more the Kd value, and if it interact less, so lesser will be the Kd value. So there occur three conditions of this Kd value. So we have a molecule which are the globular proteins, and we can have a Kd value of 0, 1 and greater than 1. So if we have a Kd value of 0, so we have a equation of V equal to V0. So how this equation comes? So we have a Kd equal to Ve minus V0 by Vi. We simply put a 0 and we just do our calculation. So that's how we get a this equation. So if we have a KD value of a 0, this molecule will be excluded from the column. So these are the larger ones. So KD value is 0, meaning no interaction with the stationary phase, so they simply get eluted first. So these are the larger molecule. And global protein having KD value of 1, meaning equation will be V equal to V naught plus Vi. So these molecule will be completely in the pores of the column. And if the KD value is greater than 1, meaning it will interact with the bead more. So VE will be greater than V naught plus Vi. So these molecule will get absorbed more on the matrix. So they can be in the pore, but they can also be outside of the pore because they'll be interacting with the beads more. And so what do we use in the gel filtration matrix? So these are the mainly used matrix for the gel filtration chromatography, but the Cepheros is the one that we basically use. So these are the different names of the same compound. So these are the Cephedex G10, G25, 50, 100, 200, Cepheros 4B, 6B. So what is the difference is because they can separate molecule based on their sizes. So just a molecule having up to 700 Dalton, then we can use Dex G10. So it is between 1000 to 5000, then we can use 25 and etc. So I hope you get the idea of the gel filtration matrix, and I thank you for your patient listening. And if you like the video, please like, share and subscribe. Thank you.